Have you ever wondered how to actually track and measure the adoption of your design system in a way that really matters? In today's video, I want to share my perspective on design system adoption. Not just the usual usage stats, but deeper, meaningful success metrics that tell you how well your system is performing across design and development teams, and ultimately, how it impacts your product quality. Before we jump into measurement strategies, let's clarify what parts of the design system we can easily track. Almost everyone uses Figma to create components, designs, and handover for developers. For designers, tools like Figma's Analytics can give you insights into how often components are used. For those who are more advanced, the Figma Library Analytics API can help build internal design system dashboards for more accessible data sharing with non-technical members. This gives us a quantitative view of adoption from a design perspective. But here's the thing. A Figma library without a code implementation is just a static reference. It's not really adopted if it's not being used in production. So in this video, I'm focusing mainly on the engineering side, the component library in code, because that's where real adoption happens. From experience, many teams try to measure adoption by simply counting how often components appear in the codebase. React libraries like React Scanner can automatically count component instances in your app and generate export-ready reports in JSON format. That's a good start. You might track something like component usage grew by 15% this quarter. Let's celebrate a 30% bump in button usage. But no one checked if they were used consistently or accessibly. I'm just joking. That kind of data can show trends. It might tell you that developers are using the system more, that things are scaling well, or that teams are building faster. But numbers like that don't always tell the full story. They don't always show the real-world impact or help you figure out the return on investment. So what does success really mean for a design system? It depends, and usually it comes down to the bigger business goals. Every company is different. For some, success might mean shipping inclusive products that meet accessibility standards around the world. That's a strong sign the design system is working. For others, it might be about speeding up development or keeping the brand consistent across every product. Numbers help, but the real value shows up in how the system supports your teams and your business goals. Components vary in their role and complexity. Some, like box or flex, help build layouts. Others, like button, input, or form, trigger user actions. When we measure adoption, we need to look at which components are being used and, more importantly, how they affect the user experience. This brings us to accessibility. Great design systems help teams build accessible UIs, with proper landmarks, area attributes, and keyboard navigation. So when we measure adoption, we should also look at how well components support accessibility goals. And accessibility goes beyond components in isolation. It's also about overall page structure, text hierarchies, and navigation patterns that are screen reader friendly and touch optimized. Now, here where it gets interesting. What if we could capture the visual coverage of your design system across an actual app, seeing how much of the screen is powered by your components? This is where I've been experimenting with a custom Chrome browser plugin. This plugin scans the entire DOM in production, detects all elements, and maps them into SVG rectangles. Each component includes a data component attribute, so we can distinguish between custom components and native HTML elements. From this, we can generate a visual heat map, showing exactly where and how your design system is being used. And because the rectangles have actual pixel dimensions, we can also measure how much screen real estate each component covers, giving us a new success metric, visual coverage. You can extract all this data, number of components, visual coverage percentage, and list of all detected components into JSON. Plus, you can export the heat map to better visualize component impact. Once you have this raw data, the next step is to make it actionable. Imagine building a design system adoption dashboard, a central place to track metrics over time, showing how visual coverage evolves, which components are gaining or losing adoption, and whether accessibility features are increasing across your pages. The dashboard could automatically crawl data daily or weekly and generate clear visual reports. Not only does this help track adoption, but it also helps educate stakeholders who may not understand what a component is, but can see the visual impact in a clear, engaging way. Using this method has helped me speed up report creation, automate tracking, and even improve stakeholders' buy-in. When people see real visual data, not just spreadsheets, it's easier for them to understand and support design system work. It's not just about fancy dashboards. It's about showing that the design system is a real quality assurance tool. It helps keep an eye on things like accessibility gaps, inconsistencies, or missed patterns, all of which are easy to overlook during design or development. This is just the beginning. You can take this further by validating things like touch target sizes across devices, component spacing in different viewports, accessible contrast and alignment. Your browser plugin could even run real-time validations, acting as a buffer that flags issues early in the development cycle. So that's my approach to tracking design system adoption, moving beyond raw numbers and into real impact. If you're interested in more examples, let me know in the comments section below. I would be happy to dive deeper into tooling, plugin setup, or accessibility checks. And if you found this helpful, like, subscribe, and stay tuned for more deep dives into design systems, adoption strategies, and building better products together. Thanks for watching.